This is just a quick demonstration video to try and show you the interference pattern from n equals 2 slits, n equals 3 slits, up to n equals 5 slits. And what I've done here is I put the laser way over here on this side of the room. And then it's hitting some slits right here. And then the interference pattern that we're going to see, whoops, wrong way, is going to show up way over here on this screen, which you can actually see a 2-slit interference pattern right there, right now. And I'm going to turn out the lights and double check the focus before I change anything here. And I'll zoom in on that pattern. You can definitely see that pattern there. If I zoom in on it, come on now. So I've got a desk lamp on one side of the room giving just enough light so I can walk around without hitting stuff. Whoops. Okay, let's zoom in on this pattern. Whoops. Sorry, it's taking so long. So by using a large distance to the screen, the pattern gets basically some angular magnification. It just gets easier to see things. All right, and there's going to be some focus issues. Give it a sec. Oh my gosh, come on. This remote is being very touchy today. Oh my gosh, there it is. Okay, sorry about that. And I think that's about as zoomed in as I can get. And that is in focus. Oh, now it's not. That's about as good as the focus is going to get. All right, so standard double slit pattern. We see the fringes are spaced equally. Let's go up to n equals 3. Let's see which way that is. That's this way. Now we should see a 3-slit pattern. Is it focused yet? Let's double check the focus. Hit autofocus again real quick just in case. Give it a sec. It's getting worse. It got worse. There is the pattern. You can see it. See that dot? There we go. Oh my gosh. Okay, finally. So what we see is a global maxima, the bright fringe, and then you got a local maxima that's much dimmer. So notice there's 2 dark fringes between adjacent global maxima there. All right. And let's go to n equals 4. Here we go. Changing 3, 2, 1. That's 4 slits. Now you see that there are 3 dark fringes between adjacent global maxima. We've got a bright spot, 2 dimmer spots, and then another really bright spot. Let's go, that was what, n equals 4? Let's go up to n equals 5. Predict what should happen. 3, 2, 1. There you go. Now we're up to 5. Notice what's happening. These global bright spots are getting farther and farther apart. Now we're seeing 1, 2, 3, 4 dark spots between adjacent global maxima. And this is to motivate the idea of a diffraction grating. If you end up with hundreds of slits, let's say you had 100 slits, then there'd be a bright spot and then 99 dark fringes with some local maxima in between, but they'd start to get so faint you can't see them anymore. And so as you get to higher and higher number of slits, what happens is you basically get bright dots separated by vast fields of darkness that, right, you can't perceive these local maxima anymore. If you want to learn more about this, you can read on page, and I'll put a link to this in the description somewhere. Let me get the page number. Sorry, it is on page 52. And that's it for that video. I just wanted to make that more visible than the last video that I tried.